So, hello everyone. In this recording, I will talk about the data types of the data and in a probability distribution functions. So the data is two type. We have the quantitative data and then qualitative data. And then for quantitative data, we have the discrete type and then continuous type. So what are they? Let me show you. The discrete is we can count. So this one is discrete. For example, what is the number of students? We can count and say that 10. What is the number of products? The result of throwing a dice. These are all discrete and you cannot say that the number of products is 10.234. You cannot say it. Or you cannot say that the number of students is 9.3567. You cannot say it. Or you cannot say that the result of throwing a dice. So result of throwing a dice is 1 by 6. Okay. It is just you count it. So how many options are there? 1 out of how many? 6. That's all. Number of defects, again, it is the discrete data. So this one is discrete. Or we can count. So let me just show you here. So we can count. Number of nonconformities. So how many defects, nonconformities do we have? And then we have the continuous data. So the continuous data is this one. We measure. Okay, we measure. But it is continuous. Because if I say what is the height of a person, you can say 1.80 meters. But it is not exactly 1.80 because it can be 1.8057. It depends, yes, on the precision of the device. A dog's weight, how much is the dog's weight? You say that 3 pounds, for example. But it is not exactly 3 pounds. It is 3.2756. Depends on which machine you use. The numbers never end. So it goes till infinity. Okay. The speed of the car. The speed of the car is not exactly 50 mph. It is 50.12315. The numbers, the decimal points, they don't end. It is continuous till the infinity. You can never know it is 50.1 or 50.11, 50.111, 50.1112. You see, the numbers never end and you can never be sure that this is just exactly 50. That is what we use as the continuous data. Today we will look for today we will look for the discrete type of the distribution functions. Let me show you what it looks like. The probability distribution. So the probability distribution, it links the value of the variable with the probability of the occurrence of the value. So it links what is the probability of process A happening? What's the probability of process B happening? What's the probability of process C happening? You see? It links the process with its probability. But from mathematics, we know that, for example, if I give you the x and then the function, you can draw how it looks like. You can draw this way. Yes, it is ax plus b. But in probability distribution functions, what we do is that you have the x-axis is not the function. I mean, so the y-axis is not a function. Y is that this one is the probability and this part is the events. What is the event 1 and what's its probability? What's event 2 and its probability? Event 3 its probability. Event 4 its probability. You link these two in a probability distribution function. It can be, as I said, discrete and continuous, and we have lots of probability distribution functions, lots of them. Okay, let me just give you one simple example here, and as you can see how it looks like. Say that I am throwing a dice. So not dice, 2 dice. Throw 2 dice. Okay, this is what I will do. So the first one, the number is 1. The second one, number is 1. The first dice, this one is the first dice. The number is 1, the number is 1. I group them according to summation. So 1 plus 1, 2. So I bring it here, 2. Okay, I throw one more dice, 6 comes, and one more, 6 comes. The number is 12. I group it here. Okay, and then one more dice, 2 comes, 6 comes, sum is 8, and then let me add it here. Group according to sum. Okay, this is what I am doing. So one more 4, and then it makes 10, 11, one more 11, one more 10, one more 5, and then we have again 8, we have 3, we have 4, we have 3, we have 7, 6, we have 9. And this way I just throw the dice, and as you can see, if I go, okay, you can see I get this axis here. This one is the probability, and this one is the event. Okay, let me show you what it looks like. So I'm saying that if I throw 2 dice, what is the probability that sum of them is 6? Okay, what are the combinations? The first dice can bring 1 and the second one has 5. First dice can bring 2, second one has 4. First dice has 3, second one has 3. First die has 4, second one has 2. First die has 5, and second one has 1. You can see how many possibilities do I have? I have 5 possibilities. But how many total possibilities do I have? 36. Okay, then it will be 5 by 36. As you can see, that it is sum is 6. As you can see, 1 5, 2 4, 3 3, 4 2, and 5 1. And how I know that I have 36 total possibilities? Because one die will bring me 6 possibilities, and the second die will bring me 6 possibilities. Total we will have 36 possibilities. Since these are independent events, you can multiply. Whatever happens for the first die is independent than the second die. So therefore you can multiply it and you will get 36. Also you can use some logical here that the combinations of the first and second die, it makes 36. Okay, or now let's look for the sum makes 7. First can bring 1, 6, 2, 5, 3, 4, and then this way you can see the possibility that it is 7 by 36. And this one is 7 by 36. And this one is 6 by 36. Is it 6? 1, 2, 3, no, sorry, 5 by 36. And this one is actually 6 by 36. And this one is 4 by 36, and then 3 by 36, 2 by 36, and then 1 by 36. As you can see, this is the, for example, what is the possibility that if I throw 2 dice and then the summation will be 2? It is 1 1. The other one, yellow, the other combination doesn't matter here because it is 1 1. They are the same. Okay. The other one is a 1 1 also, it doesn't matter. So therefore we have only one possibility out of 36. This is the discrete probability function. So let me add it here. This one is discrete probability, we can say graph. Okay. So distribution, let me just put it distribution. More scientific. So we have different types of discrete probability distribution, but as I said, all is that we have events and we have the possibility of those events. Event A, for example, event B, say that event A is rain, for example. What's the possibility that it will rain? 40%. For example, event B is sunny. What's the possibility that it will be sunny? 50%. Event C is, for example, a what weather we will have, that is foggy. What's the possibility that it will be foggy? And then you can just go here and the 60%. This is how it looks like the discrete probability distribution. Or we can go this way. Event A is the parts manufactured by 3D printing, the parts manufactured by injection molding, CNC, powder bed fusion, and then recycled material. These are the events. And then the rest is for example, the possibility of having 30 defects per 1,000 manufactured units. What is the possibility of it? And then you show in the y-axis. So we have lots of a couple of discrete probability distribution that I will cover. And the first one is hypergeometric. I will talk about in the next recording.